Hello everyone, welcome to this video on advanced usage of the request library in Python. In this session, we'll dive deeper into handling parameters and headers, two essential features when working with APIs and web servers. Have you ever needed to filter API data with specific parameters or include custom headers for authentication? If so, this video is for you. We'll cover everything from sending URL parameters to adding custom headers for API keys and more. By the end of this video, you'll have a solid understanding of how to use these features effectively in your Python projects. Let's get started. Sending URL parameters, params. When working with the request library, one of the useful features is the ability to include query parameters in your HTTP requests. Query parameters are often used to filter or customize the data returned by an API. Using the params argument in the request.get method, you can easily append these parameters to the URL without manually constructing it. For example, let's say you want to retrieve posts from the JSON placeholder API where the userid is 1. You can specify the query parameter as a dictionary userid 1. The request.get method automatically appends this parameter to the URL when you pass it via the params argument. The resulting URL will include the query parameter like this https://json placeholder.typico.com/posts userid1. Once the request is sent, the server processes it and responds with data matching the criteria specified in the query parameters. You can use the response.url attribute to verify the complete URL that was constructed, including the appended parameters. Additionally, you can pass and work with the response data using the response.json method, which converts the JSON response into a Python dictionary for easy manipulation. This approach is particularly useful when interacting with APIs that allow filtering or sorting data using query parameters. It simplifies the process of constructing URLs and ensures your requests are accurate and efficient. Whether you're fetching specific user data, searching for records, or customizing API responses, the params argument is an essential tool for handling query parameters with the request library. Adding custom headers. When working with web servers and APIs, custom headers are often required to provide additional information about the request. These headers can include authentication details, content type specifications, or other metadata needed by the server to process the request correctly. The request library makes it easy to include custom headers in your requests using the headers argument. For example, if a server requires authentication via an API key, you can pass the key as part of the headers. The headers argument is a Python dictionary where the keys represent the header names and the values represent the corresponding header values. In the provided example, the header includes an authorization key with the value bearer your underscore API underscore key, indicating that an API key is being used for authentication. The request is sent using the request.get method with the URL and the custom headers. The server then processes the request and responds with the appropriate data if the authentication and headers are correct. The response.status underscore code provides the HTTP status code, allowing you to check whether the request was successful, e.g., status code 200 for success. The response.json method converts the server's JSON response into a Python dictionary, making it easy to work with the returned data. Custom headers are essential for many real-world applications, such as making secure API calls, specifying the format of the response, e.g., JSON or XML, or including user agent strings. By using the headers argument in the request library, you can easily customize your HTTP request to meet the requirements of any API or server. Sending post requests with form data. The post method is commonly used to send data to a server, and the request library makes this process simple by providing the data argument. This argument allows you to send form encoded data. typically in the form of key value pairs, to the server. This is particularly useful when submitting forms or sending structured information to an API for processing. In this example, the URL https://json placeholder.typico.com/posts is used as the endpoint for the post request. The data variable contains a dictionary with three key value pairs: title, body, and user id. These represent the fields of a form or the parameters required by the API. The request.post method is used to send this data to the server. When the server receives the request, it processes the provided data and typically responds with a confirmation, such as the newly created resource or a success message. The response.status underscore code indicates whether the request was successful. A status code of 201 created usually confirms that the resource was successfully created on the server. The response body, which is returned in JSON format, can be passed using the response.json method. This converts the JSON response into a Python dictionary, making it easy to access individual fields of the response. For instance, the response might include the ID of the newly created resource along with the data you sent in the request. This example demonstrates how straightforward it is to send form data to a server using the requests library. Whether you're submitting user information, posting comments, or interacting with APIs, the data argument provides an intuitive and efficient way to handle form submissions in Python. Sending JSON data in request JSON. When interacting with modern APIs, it is common to send data in JSON format, as JSON JavaScript object notation is a lightweight, widely accepted format for exchanging structured data. The request library makes this process simple by providing the JSON argument, which automatically encodes your Python dictionary into JSON and includes the appropriate headers for you. In the example, the URL https://json placeholder.typico.com/post serves as the endpoint for the API. The payload variable contains the data you want to send, formatted as a Python dictionary with keys such as title, body, and user id. This dictionary represents the JSON data you want to submit. By passing it as the JSON argument in the request.post method, the library takes care of converting the dictionary into JSON format and setting the content type header to application JSON, which is required by most APIs. Once the post request is sent, the server processes the JSON data and typically responds with confirmation, including the newly created resource. The response.status underscore code indicates the status of the request, with the status code of 201 created confirming that the resource was successfully created. The response.json method can be used to pass the JSON response from the server into a Python dictionary, making it easy to access the return data. Using the JSON argument is especially useful when interacting with APIs that require structured input, such as posting data to a database, creating new user accounts, or submitting feedback. It eliminates the need to manually encode the data into JSON, streamlining the process and reducing the chance of errors. This example highlights how the request library simplifies working with JSON data, making it an essential tool for developers working with modern APIs that rely on JSON for communication. Handling timeouts and retries. When making HTTP requests, it's important to ensure that your application does not hang indefinitely if the server takes too long to respond. The request library provides a simple way to handle such situations by allowing you to specify a timeout using the timeout argument. This ensures that the request will wait only for a specified amount of time before raising a timeout exception. In the example, the URL https://json placeholder.typico.com/post/1 is used to send a GET request. By including the timeout 5 argument, you are instructing the request to wait for a maximum 5 seconds for the server to respond. If the server fails to send a response within this time frame, The request library raises a request.exceptions.timeout exception, which can then be handled using a try except block. The try except block ensures that your program doesn't crash if a timeout occurs. Instead, it gracefully handles the situation by catching the exception and printing an appropriate message, such as request timeout. This makes your application more robust and user friendly, especially when working with unreliable or slow servers. Using the timeout argument is particularly useful in scenarios where your application interacts with external APIs or web servers, as it allows you to define a limit for how long the program should wait. This is especially critical for real time or production systems where delays can have significant consequences. Additionally, you can combine timeouts with retry mechanisms to make multiple attempts to connect to the server, further improving reliability. In summary, the timeout argument in the request library is a simple but powerful tool to prevent indefinite waits and improve the reliability of your application. By handling timeouts effectively, you can ensure that your program remains responsive and avoids unnecessary delays when communicating with external servers. Practical examples. 1. Making an authenticated request using API keys. When working with APIs, it is often necessary to include authentication or additional headers to access certain endpoints or ensure compatibility with specific API versions. The request library allows you to include custom headers in your HTTP requests, such as API keys or content negotiation headers, using the headers argument. This example demonstrates how to make an authenticated request to the GitHub API to fetch details about the popular request library repository. The URL specifies the API endpoint for the request library repository on GitHub. The headers dictionary includes a custom header accept application /vnd.github.v3 JSON, which tells GitHub's API to return the response in its version 3 JSON format. While this example does not require an API key for basic access, many APIs require an authorization header with a bearer token or API key to authenticate the request. The request.get method is used to send the GET request to the server along with the custom headers. The server processes the request and responds with the requested data. If the request is successful, indicated by a status code of 200, the program prints a success message and the response data in JSON format. The response.json method is used to pass the JSON response into a Python dictionary, making it easy to access the returned data programmatically. If the request fails, the program checks the status code and prints an error message with the corresponding code, such as 404 for a resource not found or 403 for unauthorized access. This approach demonstrates how you can use custom headers to interact with APIs that require specific settings or authentication. Whether you're accessing public APIs like GitHub or working with private APIs that require API keys, the request library provides a simple and effective way to include the necessary headers and retrieve data securely. 2. Sending form data to an API endpoint. Sending form data to an API endpoint is a common task when interacting with web servers, especially when submitting user information, registration forms, or other key value data. The request library simplifies this process by allowing you to include the form data using the data argument in a post request. In this example, the URL https://http.org/post is used as the endpoint. This URL belongs to HTTP, a public API designed for testing HTTP requests. The form underscore data dictionary contains the key value pairs that represent the data being submitted. In this case, the name field is set to John Doe and the email field is set to john@example.com. The request.post method is used to send the form data to the API. The data form underscore data argument ensures that the key value pairs are properly encoded and included in the body of the post request. Once the request is sent, the server processes the submitted form data and response. The server's response status code, accessed via response.status underscore code, indicates whether the submission was successful. A status code of 200 typically means that the request was processed successfully. If the response is successful, the program prints a confirmation message and the server's response in JSON format. The response.json method converts the response body into a Python dictionary, allowing you to view and verify the data that was echoed back by the server. If the request fails, an appropriate error message is displayed, including the status code to help diagnose the issue. For example, a 400 status code might indicate invalid form data, while a 500 status code could point to a server error. This example demonstrates how easy it is to submit form data to an API using the request library. Whether you're building an application that interacts with APIs or automating workflows that involve form submissions, this approach provides a simple and effective way to send data to servers in Python. And that wraps up our video on handling parameters and headers with the request library. Today we explored how to send URL parameters for filtering data, add custom headers for authentication, and make our API interactions more efficient and secure. These techniques are incredibly powerful and will help you unlock the full potential of the request library. Keep practicing by experimenting with real world APIs, and you'll master these features in no time. Thank you for watching, and don't forget to like, share, and subscribe for more Python tutorials. See you in the next video.